Hello all, welcome to your channel DIY Community. Please subscribe to this channel and get access to exclusive content and resources. You will also become part of our DIY community where you can connect with like-minded individuals and receive support. Hello there, welcome to your channel DIY Community. So today we will see a very interesting component which is called a message bus, or sometimes it's message broker. So what exactly is a message bus or message broker? Now, if you are planning to design a very large distributed system, then you will need a central component which can actually integrate all your components, and it can simplify and make the communication efficient between them. For example, let's see this one. If this is an example of a trading floor, you can see that it's possible that there are many traders who would be booking trades, and then at the same time you will need to communicate this to other traders who would be viewing those trades, or will be like updating or canceling or doing various activities on the trade. And at the same time there will be some people who will be doing some other tasks, and then there will be a component which will be sending and synchronizing real-time prices and lot of other reference data into the system. And then there will be components which will be sending these trades out and synchronizing database and a lot of other activities happening in the real time. So have you ever wondered like how these components you can integrate them and you can communicate between them? So this is where the message bus comes into the picture, and this is what we are going to design today. Now, before we start, you need to understand what is synchronous and asynchronous communication. So I can give you an example here. You see this picture here. So all these people are waiting in a line and they are interacting with a teller at a counter here. So this is a synchronous communication, which means that you cannot leave the line here. You'll have to wait until your request gets processed. So this is a request and reply kind of scenario. But there is one more way you can actually process your information. So in the second example, here also you are communicating something, but you don't have to wait until your response comes back. You just send your request and you can do some other task at the same time. And when the response comes, it will be sent to you at your address. So in very simple words, so this is a synchronous communication where you will have to wait until your request gets processed. But asynchronous is where you send a request, but you don't have to wait for its reply. You can do other tasks and your reply comes back whenever it comes back. And this is based on subscriber and publisher communication. Now, there are various ways this could be done. So it all depends upon your requirement. We'll go one by one. So the first method is, the easiest one is, you can actually take some existing application like Apache, Kafka or RabbitMQ, and you can use them as your message broker. So you can see here the statistics here, 10 out of 10 manufacturing industries are using it, 7 out of every bank is using it, 10 out of 10 insurance company, and 8 out of 10. So it's very widely used. Similarly, RabbitMQ is very popular, and you can see that T-Mobile is using it and a lot of other companies are using it. Each one have their own pros and cons here. Now, the question is why we are designing our own message broker when you have all these established things available. One reason is if you're designing your product, like a lot of companies, they design their own custom products. So they will design their own message broker, message bus and everything. They would rely on other vendors because they want to be very specific with their implementation, which has to be like very lightweight, ultra fast and all those kind of things. And obviously the most important reason is they make money if they provide you these components along with their software. For example, if you buy a laptop and if you are forced to buy an Internet Explorer, then obviously Microsoft is making money, even though you don't want to buy that Internet Explorer, but it comes with a package. And the second reason, as I said, that it gives full control over the software. And some financial companies, they will have their own regulations and they want to have a custom requirement, so they will do their own things. So in this session we will create our own message bus, and in this session we will design it using raw socket APIs for Windows and Linux. So there are multiple ways, various ways you can do it. So in this one we will use the raw socket API, and this is for academic reasons only. And now, before we start coding, let's look at a very high level flow of message broker. So in message broker, the central component is your broker or bus, and then there will be other components which will be your client. So as soon as your broker starts, it initializes itself and it is ready to receive requests. And every time when a client connects to the broker, so broker will register that client in so basically registration here means broker will maintain some kind of data structure and it will store a proxy of that client in its memory. And if a client actually you can design it various ways. For example, in this case, if client 1 wants to send a message to client 2, so they are not connected with each other. They can either send it directly or based on certain conditions like topic or message type or something like that. So client will send a message to the broker, and broker is intermediate component here, and based on this condition, whatever it is there, it could be a topic or it could be a name of a certain client or a name of a service, something like that. And broker maintains all that information and will forward that request to client 2. And when the client 2 process that request and sends a response, and broker will receive that response and redirect it to client. Now the other way is if one clients want to broadcast the message to all other connected components, like we have seen in this case here, this one, that can be achieved with a message bus too. For example, in this case, as soon as the trader 1 connects to the message bus will register trader 1, and when trader 2 connects to the message bus, it will register trader 2, and similarly it will register all these components whichever are connected to the message bus. And every time it receives a message from any one of these components, for example, if a trader 1 sends a message, or so message bus will use that message and it will broadcast this message to all clients which are connected to the system. So there again, there are multiple ways it could be implemented. In some cases, the implementation will be that message bus broadcast this message to everyone, and the client, they will have a logic to filter out the messages which they don't want. For example, if this trader is updating price, and if this particular service is registered to receive only the price, then it will receive that message and it will process it. But if it is not registered to receive price, then it will simply drop it. And second kind of implementation is where this message bus itself maintains the information, like what is a kind of messages which each one of these clients are expecting, and based on that it will distribute the message to these clients whatever they need. So as I said, there are various ways it could be implemented. It all depends upon the requirement. So in today's session we will see how can we implement it using C++. So in the next topics we will see more efficient way how it could be, how we can achieve the similar thing. Now the basic thing which you will need to implement it is a message. If your multiple clients are communicating directly or indirectly, the basic ingredient here is you will have to first determine what kind of message protocol you are going to follow. So if client 1 is sending a message which client 2 doesn't understand, then that message is as good as useless. So you need to have some kind of protocol. To keep our discussion simple, I'm using a very simple message format where it will have a header like a sender ID, and then it will have a message body called data. Only two parts, header and data. But you can have a more complicated one where you can have a complete trade message, or if you are using a Twitter, then you can have some tweet related information or anything else. Or you can also have various derived classes out of interfaces, and the classes knows how to serialize or deserialize the message. It all depends again what exactly you need. But to keep this thing simple so that we can focus only on the message bus, I'm using a message where it has only two parts, header and data. Cool. So this is the message class. And then there is another class which we are going to use, which is, let's come back to this one later, a connection. So a connection class is like a proxy, basically. That's what I was mentioning when we're seeing that sequence diagram. So this connection class maintains a client proxy, and it knows how to communicate with the client. So it has functions like start and how to read message from client. And then there is third class which we are using here, which is called message queue manager. So the purpose of the message queue manager is it maintains the interaction between a message and the client proxy. So basically this is the brain of our application, what we are designing here. So it knows how to manage the messages, and it knows how to manage the client. And here it also, we are using it to broadcast the message. Now let's see step by step. So if you are a Windows developer, then I'm pretty sure you already know that the language, if you are writing a platform specific language, then you can use preprocessor if they have to segregate this. So because we are testing this application right now on Windows, so on our Windows stuff is active. But if you are compiling the same program or working with the same program on Linux, then this part will become active. So this is the constructor of our message. Basically it is simply initializing the member variables, and these interface functions are used to access our member variables. Now these are the static member variables of our message queue manager class, which we are describing here, so that we can access them. This is the constructor of message queue manager, and we are using a singleton here. That's why I'm using a static instance, and if the instance is not defined, we are creating an instance, but if the instance is already being defined, we are returning the instance. Now because we are writing a multi-threaded application here, so I have made it thread safe. This is very important if you're writing a multi-threaded application, to ensure that your application is thread safe and properly synchronized, data is synchronized. So we are using a lock guard. This is the function which will get executed when you start the message queue manager. So it will, again, everywhere we are using logs, and it is using a condition variable. So this start variable, start member function is running in an infinite loop, and it will wait for a condition. And the condition is, as soon as a client tells message queue manager that a message is ready, it will get triggered, and it will get the messages from this queue, and it will broadcast the message. So we have already seen here this message queue manager, it maintains list of clients, and it also maintains messages. So we are using a deck to maintain the messages, and as soon as a client gets a message, it will tell MQ manager the message is ready, and MQ manager will fetch the message, and it will broadcast to all clients. So that's exactly this code is doing here. Then there are other messages like add message. If client want to add a message to the message queue, then it will call this interface, and it will use a log guard, and it will add a message to the message deck here. This is the deck, and as I mentioned before, as soon as it adds a message, it will notify that the message is ready using this condition variable. Similarly, there is another interface function which can be used to add a client. So again, it is very important to use thread safe mechanism to synchronize your data. So this vector of clients, it maintains this list of clients, and the application will simply call this add client and send a socket, and the socket will get added to this vector here. This one is exactly opposite of the previous one. If when the client is not available and the proxy needs to be removed from the vector, then this remove client will get triggered, which will try to find the client, and it will remove it from the list. Here, client erase. And then this last method is to broadcast. As I mentioned that we are maintaining all these clients in a vector here. So as soon as the client wants to broadcast, it will call this method broadcast, and it will the application will iterate through all the list of all these clients, and it will send message to every client in that particular vector. So this is the vector, it is getting each one of them, and it is sending message to each client, and this, it's simply forwarding the message. Now let's go over the client proxy part. Now in the client connection, as I mentioned before, it is the client proxy which is mentioned in the sequence diagram before. So once again, we are segregating the code based on Windows or non-Windows here. So we are starting with a client connection constructor, which is initializing a member socket with a parameter socket. as soon as the client proxy starts, it will receive client ID. We are actually getting the request in two steps. In the first step, the client will register itself, so it will send an ID, and in the next step, and it is getting ID and it is adding the client. You can see here it is using get instance of MQ manager, and it is adding the client to that vector there. And as soon as the client get registered, it will start receiving the messages from the client. So this is start receiving message function, and it is receiving message from the client socket, and little bit of platform dependent code here. That's why we are using if def Windows or non-Windows. If there is an issue with client, then it simply terminate the connection. Otherwise, it will add a message to the message queue. Now, and we have already seen it when it adds a message to the message queue, this one gets called and it will notify the condition variable, and then condition variable, which is waiting for the messages here, it will pick the messages and it will broadcast. So all these things we have already seen before. So we're here, we are adding the message to the queue. That's it. And this is if the client get disconnected, then we're removing it. It's actually outside the while loop here. There's a while loop. It is removing the client. And there is a cleanup code here, again, which is platform independent, close socket for Windows and close for Linux. So that's all in this one here. Now let's look at our main program. So the main program is, again, we are declaring all our headers. There is some Windows specific header, WinSop, and we are including a library. If you are already including a library in your properties, then you don't have to include it here. And then there is some Linux libraries if you're testing on Linux. This is our main program. We are initializing socket for Windows, which is not required for Linux. Then we are creating a socket here. If the failure happens, then for Windows you always have to do the cleanup. Then we are binding to our socket. Every time when it fails, clean up or close. But if everything is okay, then it would be listening at that socket. Again, every time when it is failing, it is doing the cleanup. And when server is ready, it starts a dedicated thread for MQ manager start, and this is the instance, and it's a detach worker thread. So we are giving little bit of delay before we start other steps, which is where we are, that's why we are using their waiting for these many milliseconds. So the next step is it will be waiting for client connections, and as soon as it gets a client connection, it will start a client thread, and every time a new client joins, it will start a new thread, and it's like again a worker thread for each client, and this keeps happening in a loop. You can see here it is waiting for a while, waiting for client's connection. As soon as the client connection happens, invoked, it is creating a proxy. It is then it goes into that application logic what we have already discussed in the client connection, and this is a loop here basically. And when it terminates the loop, we do the cleanup. So this is all there in this server code. So these were the files in our server code. Let me close this one. So we already went over message.h, client connection, the implementation of message.cpp, and our main file. Now let's compile it to make sure it works. All right, so this is working. Next we will see a simple client. This is not that complicated. We only have one file with a main program. So again, these are some header files similar to message bus. Now you can write it more efficiently, but this is just for sample only. So this is a function similar to what we have seen before. It receives the message from server, and this thing is running in a loop. And this is our main program. Most of it is self-descriptive, similar to our message bus server. We are initializing the socket. This is Windows specific. Then we are handling error cases in case if socket doesn't get created, we are handling it. Then we are initializing the socket and trying to connect with the server. It is connecting. If it fails, we close the socket. If it is successful, then we will get client information and send it to the server here. So if that thing is successful, then we will start a client thread which will receive the message from the client, and it will keep on sending to the server, and that we have already discussed here, this part here. Receive message. So this is the while loop which will keep on receiving the messages from client, and it will keep on sending it to the server. So and we are starting on a message thread. So this is a little bit of like multitasking. On one thread it is receiving the messages from the server, but on the main thread it will it will let user type whatever user wants to type, and it will send it to the server. So basically on one thread it is sending the messages to the server, on the second thread it is receiving the messages from the server. So once the user stops, it will perform the cleanup and it will exit. That's all with the client. Let's compile this too. Now let's get back to the demonstration. So our demonstration, you have to remember this scenario here. Think that our message bus is this message bus here, and there are multiple clients which are sending messages to the server, and server is broadcasting it to all other clients. So let's start the server. Okay, so the server has started and it is listening on port 8080. Then we will start message bus client. This is the first client which we have started. Let me arrange it a little bit so that we can see multiple screens at the same time. Right, this is the first client. Let's wait the client here, and then we'll start another client. This is the second client, and then we'll start one more client here. This is the third client. Okay, I think this is enough. Now you can see here these server log messages are telling you that it has started receiving connections from the client, but they're not connected yet. I think, let's see. So this is the ID of the first client, but as I said, I just wanted to keep it simple, so I'm using client ID, but you can have topic, and based on the topic you can have clients which can receive those messages. So it is sending a message like it wants to buy Apple 100 stocks, something like this, right? It can be more sophisticated, but this is just a demonstration here. Now those two clients are not connected yet. Let's start connect them to 102 and 103. Now let's get back to our clients. Okay, here, one here, and one here. Okay, every time I'm losing the second one. 1 second. Let me make it smaller. Let's see. Type here. Say Apple 100 stocks, sell. So you can see as soon as this client has sent the trade message, rest of the clients have already received it. And when this client send it, Tesla sell 30, all other clients have received it. So this is how asynchronous message comes. You can see that this is these are all connected with the message bus, and they are free to do. It's not like they get stuck when the server is processing it. So this is how, guys, a message bus works, where we have seen how to establish asynchronous communication between client and server. So that's all for today. Thank you for watching. Thanks for watching. Please subscribe to get more professional advice. In addition to our free online content, we also offer free online classes for students. These classes cover a range of topics, and they're designed to help you enhance your skill and knowledge. We encourage you to join us and take full advantage of this opportunity to learn and grow.